Hi everyone, welcome to my channel Pure Biology, and today I come with another video and that is related to the inbreeding and Hardy-Weinberg principle, and it is totally calculation is done here by the analysis of pedigree, okay, and which students or anyone viewers, if you know about the pedigree, then you can understand this topic properly. But if you don't understand or don't know about the pedigree analysis, so first you check out the videos already uploaded in my channel. So you just check out the pedigree, how to calculate the pedigree, and then you come here to understand this one, okay. And obviously subscribe my channel and hit the bell icon for getting the notifications of all my videos, okay. So here the calculation of the inbreeding coefficient from the pedigree analysis, and this calculation is done by the path diagram rules. Here are some rules. First you have to learn these rules and then you can calculate this coefficient. F1 is the coefficient you can calculate. And here first rule is that identify the common ancestor. First one is that you have to identify the common ancestor. Second one, all positive paths must be counted. Third one, for each path count the individual. That means one path that is connected with the individual, so individual number is calculated first. Every path must have one and only one common ancestor. One path that has only one common ancestor. Only one. The contribution to the inbreeding coefficient, the calculation, it is the formula half to the power n into 1 plus Fa. And here n is the number of individuals including the common ancestor but excluding the inbreeding ancestor. And Fa is that common ancestors inbreeding coefficient. If common ancestors, these are involved in the inbreeding process, so its coefficient is that Fa. And if common ancestor that is involved in inbreeding process, then Fa that not be 0, it has some value. But if the common ancestor not inbreed, these are not involved in inbreeding, that means Fa always be 0, okay. And the inbreeding coefficient, how to calculate? Just sum of contribution of individual paths. This is the actual just rules. And here the first case, and here I want to say that this square is the male and the circle, this is the female, and this is one tree of the pedigree, and how to calculate from this pedigree that F1. So first you just see here that A and B directly linked or in a same family, that A and B, or you can say that A and B, from A and B the linked gene, that is from AB is the D and E, okay, directly linked with the A and B, that is D and E, and C and F that are coming from other family or other individual population, you can say. And then G and H also, these are directly linked with the D and E, okay, and from G and H I also linked, okay. So this pedigree tree is first you have to draw a short path by which we can easily calculate this F1 value. So how we do that, or how can do this diagram? First, from A the D is connected, so from A straight line D is connected, and from D G is connected, so D is directly connected with the G. In the same way, B is connected with the directly E, and E is directly connected with the H. And here A is also connected with the E. A is also connected with the E. You can see that E is connected with A also, and D is connected with B also. Okay, so here A and B connected with D and E by the cross linked or cross path. Clear? So here the first one is the F1 generation, first two is the F2 generation, this is the F3 generation, and the last one is the F4 generation. Clear? Now you can see the two paths. What are the two paths? That either G, D, B, E, H. In such way you have to calculate like that. G, D, G, D, A, E, H and I. Okay, this may be one path, or another you can say in that path. What are these? G, D, B, E, H, I. Okay, this may be one path and this may be another path. So if you calculate this, you just observe this path route, then you can identify the 5 individuals, both all are directly connected. G, D, A, E, H and G, D, B, E, H. Because I, why we are not taken this I? Because here if we take I is included with G and H both, because G and H both are common here. In for not G and H common, I is common for G and H. Okay, so one common individual is that I. So we have to take either in such way or in such way. Okay, and so here the number of individuals in first case is 5, N is 5, and in the second case N is also 5. Now 1 plus FA. FA means what? FA means common ancestors inbreeding coefficient. So you can see here no inbreeding process is seen. So inbreeding process is not seen. That means FA is 0. In the both cases, first one in when we take FA, that means FA is 0, and the second path, the FB, that is also 0, because inbreeding is not occurring both the root. Clear? So that's why the value becomes FA is 0 and FB is 0. Clear? So if you calculate this one, so half to the power 5 and half to the power 5, if you calculate this one, so answer is 1 by 16. Clear? This 1 by 16 is the F1 value. So in such way, we can calculate the coefficient or F1. Coefficient of what? Inbreeding coefficient. Okay, inbreeding coefficient we can calculate, that is the F1. Another example or another case I just explained for getting the topic more properly. Another example I have to explain you. So you just wait for the second one. Okay, so this is another pedigree tree, that here A is connected with Q and P. From Q this is B, and from A and P this is C. B is from A and Q, and A and P, from A and P C is developed or C is formed, and from C and N E is formed, and from B and M D is formed. From D and E common ancestor is not common ancestor, common the recent one is the I. Okay, and here the shortcut path that are directly connected with the family gene, that is coming from A is directly connected with the B. B is directly connected with the D, and from this side A is directly connected with the C. C is directly connected with the E, and E and D both are connected with the I. Okay, the common ancestor is this one. This is not. So the path is like that. How it is formed? D, B, A, C, E. Okay, and here the common ancestor is the A and I is the recent one. Okay, last generation individual. So here the number of individuals we have to take D, B, A, C, E, not the I. The last one or last individual, last generation individual is not calculated. Common ancestor is calculated, and just before the last generation we have to calculate. Like that, it is the F1 generation, this is the F2, F3, F4. So F4 is not calculated here or counted here. Up to F3 we have to calculate. Clear? So the number of individuals here 5. A is 5, and you can see that A is not interbred. Okay, that's why here the FA value is 0. So F1 value is 1 by 2 to the power half to the power n, and 1 plus FA. So FA is 0, that means half to the power 5. Answer is 1 by 32. Clear? So in that way we have to calculate the F1 value, or from the pedigree tree we have to calculate the F1 value. Okay, so I think you understood this topic, and next in my next video I will describe another topic. Okay, so you just check out my channel always. Thank you.